Hey folks, welcome to my channel number pen. So there we have the problem on our screen. Differentiate the following y equals x to the power cos x, right? So here we have a function of the type y equals f of x to the power g of x, right? Now, in this problem, I don't think a substitution is going to help us out because we have two functions. We have a function x and then we have another function cos x, but the function y is x to the power cos x, right? So by making a substitution, I don't think I can simplify y further, to an expression whose derivative we are quite familiar with and you can directly apply it by first principles, right? So whenever you see a function of this type, y equals f of x to the power g of x, or if I may call it u to the power v, where u and v are two functions which are again dependent on x, right? First step would be to see if I can simplify this particular problem by taking a logarithm on either side, right? So far we saw problems based on chain rule where we make an appropriate substitution and then apply the chain rule to arrive at a final answer. In this video and in some of the other videos that are to follow, we will solve problems by taking logarithms on either side. And let's see this particular problem, how we are going to solve this, right? So when I take a log on either side, my log y becomes equal to log of x to the power cos x, right? This is where what we are actually doing is we are again simplifying the entire expression, but this time we are doing it by taking a logarithm on either side. And why are we doing this? Because when I take a log on either side, my log y equal to log of x to the power cos x, which is nothing but we're quite familiar with this expression, cos of x log x, right? So now I am able to convert this original expression x to the power cos x into an expression of the format cos of x into log x equals log y, right? So now I'm familiar with the derivatives of log y, cos x, and log x, right? And then I know which rule to apply on this particular problem, right? So what do we do next is go ahead and differentiate on either side, right? So when I differentiate on either side, I get a 1 by y because my d by dx of log x is 1 by x from first principles. And remember, folks, we are differentiating this with respect to x. So I will have a dy by dx here. And then I have a cos x, I have a log x, right? So what does this mean? We have a product of two functions. So it is of the format uv, where we are quite familiar with what to do. When I differentiate this on either side, I first take the function cos x, right? And then I differentiate it. All I'm doing is applying the product rule of differentiation, right? So d by dx of cos x is minus sin x. And then I write log x as it is, which is my second function. And then I take my second function, which is my log x, and let me call it by a different color green. And then I differentiate that. And what do I get? My d by dx of log x is nothing but 1 by x. And then my cos x remains as it is this time. So my second part of the expression is cos x by x, right? So there I have an expression in front of me where I have my dy by dx, but it is in terms of x and y, right? So let me rearrange this for you folks. So my dy by dx is nothing but y times, and I'm going to open my bracket here, y times minus x sine x log x cos x, right? So this is what I have. So now I have an expression in terms of x and y, right? So what is my y? My y is nothing but x to the power cos x, right? Because that's the original expression. I go down and I substitute y as x to the power cos x, right? For cos x into I copy this as it is. Can we do a further, can we do any further simplification to this expression what we have on our screen? I think no, and therefore we will leave it as it is. And my final answer is dy by dx equals x to the power cos x, open bracket, minus x sine x log x plus cos x, the whole divided by x, right? So let me highlight it in pink. That's the usual color we've been using to highlight our final answer. I hope you found this video useful. Please do subscribe to my channel and support. Thank you.